So we're over in Eclipse now, and I've already created a project, and I've also created a CPP file called rpn-calc for a reverse Polish notation calculator. And I've done a few pound includes, so pound include for IOStream, stack, and string. I also have our line in there for using namespace standard. So now we're ready to write the body of the main function. So the first thing we'll have is just a welcome statement to the user. So we'll say maybe cout, and then we'll say maybe welcome to the RPN calculator. So we'll have that as our very first line. And now we have to start thinking about how this calculator is going to work. Really what's going on is we just have the opportunity for the user to input either operands or operators, and if they enter in an operator, then we should be performing some particular operation based off of the previous operands. So really what we're going to have is just a looping structure, and we'll just have an infinite while loop. So we'll say while true. And inside of that we can write some particular condition in order to maybe end the program. So the basic looping structure is going to be to maybe display a prompt. So a prompt for our calculator. And then we'll get input from the user, so the input could be valid or invalid. And we'll have to process that input in some way. So we'll maybe check for it being a numeric value. So we'll check that, and then we'll also check for it being an operator. And maybe we'll also check to see if they want to quit. So we'll check for quit. And the last thing that we'll have is if it turns out that none of those conditions are true, then we'll output to the user that they have maybe invalid output. So we'll do some type of invalid output statement. So that's pretty much what's going on in our loop structure here. Before I guess we get to the loop structure, let's go ahead and create our stack. So we'll do a stack, and we'll say that we're going to allow fractional parts. So we'll say that our stack is going to be of type double. That way we can have a decimal point and some values after the decimal point, and we'll just call it maybe a calc stack for calculator stack. And the other thing that we'll have outside of this looping structure is a string for input. So inside the while loop here, we'll just follow our pseudocode and start writing our code here. So for display prompt, we'll have cout, insertion operator, and the prompt we'll use is just the two greater than symbol. So it looks like the extraction operator, but it's just a string literal that we're going to be using for the prompt to the user. So that's our prompt. In order to get input from the user, we'll just use cn. So we'll do cn extraction operator, and we'll extract wherever they type in into our variable called input, which is of type string. And then for checking to see if they typed in a numeric value, we're going to be making use of a new class, and we need to do a pound include to make use of that class. So the pound include is going to be pound include, and it's going to be sstream, which stands for string stream. And I mistyped stream, but string stream. And what this is going to allow us to do is make use of a class called iStringStream, which allows us to manipulate strings as if they were input streams. So I'm going to try not to say that too many times. So what we need to do is declare a variable of type double first, because we're assuming that the string in this case, or we're going to be testing to see if this string is going to be of type double or of type n, basically a numeric quantity, negative or positive with potentially a fractional part. And the way that's going to happen is we'll just write an if statement here and make use of this iStringStream class. So what we're doing here is constructing a iStringStream object from the iStringStream constructor. Should have picked something else here. So iStringStream, and we're going to pass to that constructor our input variable. And then what we're going to do is, once we create that object, is try to extract it into this variable called num. So it's allowing us to read from this thing as if it was a stream, just like what we do whenever we're trying to extract stuff from the console. So if that ends up succeeding, then the if statement will be true, and we can push that num value onto our stack. So let's not forget what we're trying to do here. We're trying to simulate a reverse Polish notation calculator. We could also say it's a postfix notation, so the operator is coming after the operands. So what we're trying to do now is just simply test to see if we have a numeric value. If we have a numeric value, then this condition will be true, and we'll want to push that numeric value that will now be stored in this double called num onto our stack. So we'll say calc stack, and then use the push function, and then we'll push on num there. So that's pretty much it for checking for the numeric value. Now, in terms of checking for the operator, what we'll do here, we'll just have this as an else if statement. So we'll say else if, and here we'll probably write a function, and we'll test to see if it's an operator or not. So we'll say is operator, and we'll write that function a little bit later. And we'll pass to that our input string, and if that turns out to be true, so is operator is going to be a Boolean returning function, we'll call another function that we're going to call maybe perform op, so perform operation, and we'll pass in our string input, and we'll also pass in a reference to our stack called calc stack. So we need to pass that in as well so that we can pop off the operands. So we'll finish off our main, and then we'll go in and write our is operator and perform op. So for check for quit, we'll just have a simple else if statement here. So we'll say else if input is equal to maybe lowercase q, so they can type in lowercase q to quit, and we'll just do a return statement there. So we'll do a return 0 just to indicate that we exited the program successfully. And for our invalid input part, we'll just have an else statement, and we'll just simply have cout insertion operator and say invalid input. That way we're just informing the user that they inputted something that we don't know how to handle. So we'll just say invalid input. So that's pretty much our main there. And now what we'll do is go in and start writing these two functions. So we'll write is operator and perform ops. So down below the main function, we'll start writing our is operator function. So it's a Boolean returning function, so we'll have bool there, and then we'll have is operator being the name of the function. And the only thing that we're passing in, as you can see here from the function call, where we have is operator, is just simply the string value that's stored there in input. So we're going to pass that in by constant reference since we don't plan on changing it. And anytime you're not going to be changing a value that you're passing into a function, you should pass it in by constant reference. So we'll have const string ampersand, and I'll just use the same name there of input. Really doesn't matter what name you use. So we have that, and inside of the body of this function here, what we're going to do is create a string array that has all the valid operators. So we'll do that by just doing string, and we'll call this string array called ops, and use our open square bracket, close square bracket, and we'll use our shortcut where we actually do the creation and initialization of our array all in one line. So we'll do open brace here and specify a minus for subtraction. We'll have a plus for addition. What else? Multiplication, so we'll do the asterisk symbol there. And the last one we'll do is just the / for division. So we have those operators there. And what we'll do now is just use a for loop. So we'll say for int I, assignment statement 0, as long as I is less than 4. So I'm going to just hard code that value in there. And then we'll do I++. So we're just creating this for loop here so that we can cycle through all these values or all these operators here that we have in our string array called ops. And what we want to do is test to see if our input value is equal to any of those. So we'll just test to see if our input value is equal to a particular element of the array by just specifying ops, open square bracket I, close square bracket. And if that turns out to be true, then we can just simply return true in that case. And what that's indicating is that we found a valid match or a match here in our array, and we know that we have a valid operator. If we go through this whole entire for loop and we don't find a match, then we'll need to return false. So that's it for is operator. I guess the last thing we need to do is just copy the header up here to create a function prototype. So up above main, we'll just do a paste here and put a semicolon, and now we have a function prototype for is operator. So now that we've written the isOperator function, we'll go in and write the performOp function. So the performOp function is going to take two parameters. One is going to be a string and the other one's going to be our stack. And we'll pass in the string by constant reference and we'll pass in our stack by reference. So let's go ahead and write the header for that. So it's going to be a void returning function. It's called performOp. And we're going to pass in a constant reference to our string. And we'll just use input as the name. So it's really up to you what you want to name that. It doesn't have to be the same name as what we had there in the main function. And then we'll pass in a stack, and it needs to be a double stack. So make sure you put double there. And we're going to be passing that in by reference. If we don't pass it in by reference, we'll have problems in terms of actually manipulating or changing what's on that actual stack. So we'll do calc stack is the name. Again, it's up to you what you want to name that. And then we'll hit return and do an open brace and then start filling out the body of this function. So on the stack here, whenever we call performOp, hopefully the user has pushed on two values, two operands. One's going to represent the left-hand operand and the other one's going to be representing the right-hand operand, and this input is going to contain a valid operator. So what we'll do now is just declare a couple of variables to keep track of our left-hand operand, our right-hand operand, and also the result of performing a particular operation. So these will be double values, and we'll have lval for our left-hand operand and rval for our right-hand operand. It's really up to you what you want to name them, but I think those are pretty good names. And then we'll do result there. So all those are of type double. So the next thing we need to do is that our calc stack hopefully will have two values that have been pushed on. And the very last value that was pushed on, or the second value that was pushed on, which would be the last value, is going to be our right-hand operand. So what we're going to do is retrieve that value by using our top function. So we'll say rval assignment operator and then say calc stack dot top, and that'll retrieve the value that's on the top, and then we can go about popping it off. So what I'm going to do is just grab this little bit here, copy that, and paste it down here and change top to pop. And that's going to be all for getting the right-hand operand value and then popping it off. And we'll do the same bit of code here. So I'm going to go ahead and copy these two lines of code here and paste them down below. And the only thing that we need to change now is this rval to lval. So we're just wanting to get the right-hand operand and the left-hand operand stored in those variables and popped off of the stack. And once we've done that, we can then start doing a comparison to see what operator we actually have. So what we'll do here is write an if statement. So we'll say if input is equal to, let's say the minus symbol, then we'll do subtraction. So we'll just calculate result by taking the lval and subtracting off the rval. So that's our right-hand operand being subtracted from our left-hand operand, and calculate result from that operation. If this is feeling a little bit uncomfortable or you're bothered by this, then that's probably a good thing, because I'm bothered by what I'm doing right now as well. But I think I'm going to leave this in here, and the reason why is I think in a later video we'll come back and refactor this code. And the reason why I want to discuss this is that up here in our isOperator, we did a comparison between our input and all of our operators here. And even though we're just checking to see if we had a valid operator, whereas down here we're checking to see which operator we actually had, we're still doing the same type of comparison. Really shouldn't replicate code like that where we're really doing the same operations. So I'm going to proceed with this, even though it's probably not the best way for us to do this particular program, but we'll come back in a later video and look at refactoring this code. So I'm going to continue on and just do an else if statement, and we'll test to see if input is equal to the plus symbol for addition, and in that case we'll calculate result by doing lval plus rval. And what I'm going to do now is try to save a little bit of typing on my part and copy this, paste it down below, and we'll just change the plus symbol up here to the asterisk for multiplication and do the same thing for the result line. And now, since we've already validated whenever we call performOp that we have a valid operator, so it's either the minus, the plus, the asterisk for multiplication or the / for division, then we can just write an else statement here, since we know that we have to map up to one of those. So we'll have else and then calculate the result as being LVal divided by RVal. So we can do that. And once we have that, we can now output to the user by using cout and output our result and just do an indel. And the very last thing that we need to do inside the body of this function is to push the result on the stack. If we don't push the result on the stack, then we won't have that result available for future operations. So we'll say calc stack dot push, and we'll push our result onto the stack. The last thing that we need to do, I guess, before we try to compile this is to make sure we have a function prototype. So I'm going to go ahead and copy the header here and go up to the top, paste the header and add a semicolon. So now we have a function prototype there for perform op. Let me scroll back down and make sure I haven't left out anything. So I think all of this looks good. We'll go ahead and save it and try to build it. So it looks like everything built okay, and now we'll run it. So it says, welcome to the reverse Polish notation calculator. So at the prompt, we can start inputting our operands. So I'm going to input some operands that have a fractional part. So I'll say 2.3 and then press enter, and that will push that particular value onto our stack. And then I'm going to put in another value, say 1.4, and hit enter, and now it pushes that one on the stack. So that should be 1.4 should be our right hand operand. And now we'll perform an addition. So I'll put in the operator of plus and hit enter, and you can see the result of that is 3.7. So I'm going to put in another value. Since we already have 3.7 as the result pushed onto the stack, we can do something like this. We can say maybe 1.2, hit enter, and then do a subtraction operation. So we'll subtract 1.2 from the 3.7, and if I hit enter, you'll see that that says 2.5. So it looks like everything is working out well. It should even work for negative values. So if I was to maybe type in negative 1.1 and hit enter and then do the plus operation, you can see that now it says 1.4. So it even works for negative values. If you want to quit, you can just press Q and hit enter, and that will quit the program. So that's pretty much it for what I wanted to do in this particular program. I would encourage you to maybe go and add some additional functionality or try to improve upon the program that we created here. Certainly we could make some improvements here in the perform op and the is operator function, just because we have some redundancy there in terms of our code, even though we're using it for two different purposes in terms of these comparisons. But hopefully the big picture idea from writing this is to see how using the stack data structure could be used in maybe a more interesting program that could be possibly more useful to you. So that's it for this particular video.